Hi, I'm Fabio Basil, a 3D artist and animator, and welcome to this demo where I'm going to take you step by step through my process of rigging and animating a Harley Davidson Street Glide motorcycle. I'll be breaking down my process into 4 parts. First, I will go over my use of masks to manage and animate Maxon Redshift materials in relation to each component of my Harley. Next, I will showcase my method of using skeletal joints to rig and animate the bike down to the smallest details. I will then explain how I create useful in-viewport user interfaces to control my Harley quickly and efficiently. And finally, I will demonstrate how to use simple Maya nodes to control lights and digital screens. These include control joints for the rotation of the wheels, joints controlling the front steering, root joints to allow the bike to lean, hydraulic controls for the rear, joints controlling the front suspensions, joints controlling the clutch lever and pedal, joint controls for the brake lever and pedal, kickstand controls for the mirrors, and finally joints controlling the dashboard gauges. Since almost no component on this bike will need to flex or bend out of scope of its original shape, I have simply parented each major component group of my bike to specific joints. This method has multiple advantages to simply parenting object groups directly to geometry. Skeleton joints inherit their rotation and position from their parent joint, which makes it easier to create rigs where some components must rotate along a tilted axis, such as a steering wheel or the handlebar of my Harley. At this point, I could simply animate each joint of my Harley's skeleton, but that will just be horribly inefficient and confusing. So to make things easier for myself, I have used curves and NURBS objects to build an in-viewport interface to control the rotation and translation of each major joint that controls my Harley. The reason why I have used curves and NURBS objects is that Redshift does not support the rendering of NURBS and curves, which is very ideal for this particular pipeline requirement. Of course, should I convert to a different rendering engine that does support NURBS rendering, my approach will involve creating a dedicated layer under which all of my finer controls will be treated as template objects, hence making them invisible, but still selectable in the outliner. Finally, this is the part where I get to animate all luminous materials on my Harley. This bike is equipped with a number of light functions, such as headlights and taillights, turn signals, a backlit dashboard gauge cluster, an LED cluster for the steering handle controls, and a digital touchscreen that displays different information and content. As I mentioned earlier, I use masks to filter and manage coverage of my materials on the Harley. Some sets of these masks also control the visibility and position of luminous shaders. These masks are just simple UDIM texture maps, so if I wanted to simulate turning on and off the headlights and taillights on my bike, all I will have to do is animate the color gain channel of that mask accordingly. Just like the process of animating hundreds of tiny anonymous joints in a skeleton system, the number of luminous materials for this vehicle is just too high, which prompts me to come up with a clever way to directly control all of these channels using clearly labeled nodes in the hypershade, which I can quickly filter, retrieve, and animate according to the type of animation sequence I want to achieve. For this purpose, I have used luminance nodes, which are default Maya nodes designed to output an RGB range from absolute black to absolute white. Using the connection editor, I can link the output color channel of a luminous node to the color gain channel of any texture I want, and I will then be able to control a specific texture without having to relentlessly search for it within the hypershade. Lastly, we have just one last problem to solve: the touchscreen. The reason why the digital screen presents a problem is that the screen is designed to show different texture maps to simulate different pages within the scope of an infotainment system. Luckily, Maya comes with a very powerful texture blend node. Just like the luminance node, the texture blend node is a default utility, which comes with great advantages and a few disadvantages. First of all, this particular node allows the loading of a large number of textures. However, I have found that errors will arise when rendering and switching across more than 8 maps. This might be a Redshift limitation, so in this case I have limited the number of my digital touchscreens views to 8. While the texture blend node is very powerful, animating every single feature across a large array of textures isn't very efficient, which is why I have resorted to a simple hack. By linking a visibility toggle switch of my texture blend node to an array of Maya float output nodes, which is a node that outputs only float numerical values, I was able to create a simple system by which I will be able to turn on and off different screens by simply changing the numerical value from 0 to 1. As you can see, I can now control my touchscreen almost in real time. It goes without saying that this method can be refined even further, perhaps even to the point of using in-viewport interfaces as controls. This was the end of my demo. I hope you have enjoyed it, and see you next time.